Good morning, students. Today we are going to see the next topic, that is region based approaches. So, here first we will be seeing what is mean by that region based approach. After that, different methods in region based approach, that is regions growing and region splitting and merging. These things we were discussing in this topic. So, actually, when we are seeing about region based approach, it is one among the type of image segmentation. Actually, generally when we say about image segmentation, we are having three types: region based approach, edge based approach, boundary or threshold based approach. In that region based approach is one among the type we are familiarly using. So now we can see what is the region based approach. So when we here first we want to see what is mean a region. So when we are seeing about regions in an image are group of connected pixels with similar properties. In an image, when pixels are having similar properties and when subject to group, that group we can call it as region. So when we are partitioning an image into various segments, so here we will follow some similar property to carry out similarity between each pixel for grouping purpose. That each group we can say it as region, so or we can say it as segment, or we can say area, like that. So region, now you know what is meant by region. In the region approach, each pixel is assigned to a particular object or particular object. Each will have some each will have some similar property. In a region, many pixels will be there and all will have similar property. Like that, various regions are there. Various regions will be there in an image. So how this region is framed? How this region is framed? Here we want to see. So when we are seeing about region, how it is framed, there is two methods are there. One is region growing and another one is region splitting and merging. Region splitting and merging. So first we can see about region growing. So when we are saying about region growing is an approach to image in which neighboring pixels are examined and added to a region class. So what we are doing, how this region grows. So initially we will select some pixel, and from that when we are nearby neighbor pixels we will examine. So we are examine and see whether it is connected with the corresponding property what we have taken. We verify with that homogeneous criterion property whether it is satisfied. If the neighbor pixels are satisfied, we will combine that. We can say it as region goal. This process is iterated for each boundary pixel in the region. So nearby all the boundary pixels, neighbor pixels, we will examine that whether it is satisfying that homogeneous criteria or property. So region growing, when we are saying about region growing requires a seed to begin with. When we are saying about region growing requires a seed to begin with. So how that region is framed? First we will take a seed pixel, and after that we slowly grow that and frame a region. Region one requires a seed to be. Ideally, the seed would be a region, but it could be a single pixel. A new segment is grown from the seed by assimilating as many neighboring pixels as possible that meet the homogeneity criterion. Homogeneity criteria. The resultant segment is then removed from the process. The resultant segment is actually once we have grown a region, when you framed a region, after that it is isolated, and next we will start next region to framework. A new seed is chosen from the remaining. This continues until all pixels have been allocated to a segment. So like this we will create so many segments. Like this we will create so many segments. So when we are seeing about this, selecting a seed, that is here the thing is we want to select a seed, and in the seed we will have select one homogeneity property, homogeneity criterion. For examination purpose we will select a homogeneity property or criterion for examination purpose evaluation, and to merge with this homogeneity criteria generally it depends upon the type of image and the type of application we are taking into consideration. Taking into consideration. So in this, when we are seeing about this region growing algorithm, so what is the thing? Two, three stages are there. First, selection of seed. There we will see one homogeneity criteria, and neighborhood pixels we will see whether it is connected with that homogeneity criteria. If it is connected, it will be merged with it. So this will be the algorithm. This will be the region growing algorithm. This is continued, iterated again and again. It will be iterated again and again. So this will be the, we can say it as this region growing algorithm. This we can say it as a region growing algorithm. When we see about the advantage of this region growing, the borders of regions are perfectly thin and well connected. So that is one big advantages of region growing. And we, with this algorithm, when we are region growing, it will be a very stable land with respect to noise. So region growing, when you see, it will be very stable with respect to noise. So next we are going to see next approach, that is a method in region is a region splitting and merging. Region splitting and merging. So when we say about region splitting and merging, it is a top-down approach. Here, what we will take the whole image, and we will see any variations are there. We will see any variations are there. If variance is there, we will split that in different quadrants. And then after splitting into quadrants, we will see any possibility to merge these quadrants based on the homogeneous criteria. If based on the homogeneous criteria, if it is possible to merge, if it is possible to merge this, merge these merge these quadrants, then we will merge that. So this is the scenario. This will be continued when we are seeing on to examples. Here to black and white is there. So first when we are seeing the image, variance is there, two colors are there, so we will apply split. After that, after splitting into different quadrants, we will try to merge any possibility to merge the quadrants. So when we are seeing this, for R1 and 3 are of same homogeneous criteria, so we will merge that. R2 and R4 are same homogeneous criteria, so we, and then the images get automatically getting segmented. So like this we are, another one example. When you are seeing this here, there's when we are seeing the image, two colors are there. When you are seeing the image, two colors are there. So we need to carry out segmentation. We will be splitting the image into different quadrants, splitting the image into different quadrants. After that, we will approach to try to merge that. When we are trying to merge that, here there is the merging option. The quadrants are not homogeneous, so we are not able to merge that. So then again we will apply splitting. When we then again we will see the quadrants homogeneity criteria, whether it is variance or not. So when we see about R1, R4, there is no variance, so no need of splitting. When we are seeing about R2 and R3, there are some variance in the image pixels. So white and black both are there. So we subjected to splitting, again splitting. Then we will see after splitting we will compare with the quadrants, nearby quadrants. When we are seeing R1 and R2 and are same, so then we will merge that. And R3 will also have the same homogeneous property of R1. So it is merged with R1. And rest of the things are having homogeneous with the R4. So like this it is merged. Now the complete image is able to segment it into two. So this is the way we will follow, and based on that we have created the algorithm also, splitting and merging algorithm. That is the process of split and merge is given best. That is, we will start the whole image. If variance is too large, we will break into corner, merge. Then at a similar level. These steps are repeated again and again. So this is the approach we are following in region splitting and merging. Okay, so like this, these are the two techniques we are following in region based approach.